Hello, friends. Today we are going to discuss the second topic in series and progression. If you would recall that the last discussion was about the arithmetic progression, now this video lecture will be talking about the geometric progression. So let us try and understand what geometric progressions are basically. This is an example 2, 6, 18, 54, 162. Now, to be very sure, this cannot be an arithmetic progression. Why? What is the difference between 6 and 2? 4. What is the difference between 18 and 6? 12. So it cannot be an arithmetic progression. Is it a geometric progression? How can we find that out? We'll try and find that out, but before that, let us try and understand what geometric progression is. Geometric progression basically is a series in which the ratio between any two consecutive terms is equal. Ratio, and how do we calculate the ratio? The ratio is calculated using this formula, the latter term divided by the former term. What does this mean? In the above series, if I have to find out the ratio, it would be the latter term divided by the former term, or 6 divided by 2 is equal to 3. Now let us take the second and the third term. Again divide the latter term, which is the third term, by the former term, which is the second term. Again the ratio is 3. Likewise for the fourth and third term, 54 by 18, again it is 3. 162 by 54, again it is 3. The ratio is same across the series, throughout the series, and that is why this series will be a geometric progression, because the ratio is same between any two consecutive terms. Is this okay? Now please make sure that the calculation of ratio has to be using this particular formula, latter term divided by the former term. So if you are trying to calculate the ratio using the first two terms, the second term divided by the first term. Second and third term, if you are using, then you will have to do what? You will have to divide the third term by the second term. Don't do the opposite. That is, don't divide the former term with the latter term, otherwise it would go all wrong, right? Keep this particular thing in your mind. So what does this ratio, or what do we call this ratio? In arithmetic progression, what was the difference? The name that we had given to the difference was common difference. Likewise here, the ratio would be called common ratio, because the ratio is same across. The ratio is same throughout the series, and that is why we are using the term common ratio. In any geometric progression, again the first term again is denoted by a, as was the case with arithmetic progression. Let us take some examples. 1, 10, 100, 1000 and 10,000. What is the common ratio r? 10 by 1, 10. 100 by 10, 10. 1000 by 100, 10. 10,000 by 1000, 10. So basically the common ratio is 10. It is a geometric progression because the ratio is same throughout the series. Again, let's take another example. Deliberately, again I've taken a negative, I've dealt with the negative numbers deliberately so that you are able to better understand the concept. -3, -12, -48, -192. Now -12 by -3, it would be 4. -48 by -12, again it would be 4. Likewise for the fourth and the third term, if I have to calculate the ratio, -192 by -48, again it would be 4. So the common ratio is 4 throughout the series, and that is why again this is also a geometric progression. Another example, -5, 10, -20, 40, -80, 160. Let us try and divide the second term with the first term to find the ratio. 10 divided by -5, -2. Third term divided by second term, that is -20 divided by 10, -2. Likewise for the fourth and third term, -80 divided by 40 would be -2, and likewise for the fifth and the fourth term, 160 divided by -80 would be equal to -2. So again the ratio is same throughout the series, and this is basically a geometric progression. So now let us try and find out the method let us try and understand how do we find out the nth term of a GP. Again, as in AP, you have to be very sure that before you are using this particular formula that we are going to discuss in a little while from now, TNA into r raised to the power n minus 1, before you use this formula you have to be very sure that actually the series on which you are applying this particular formula is a geometric progression. How can you be sure about this? You have to test the ratios. So the ratios should be same throughout the series, then only it is a GP, and then only you can apply this particular formula. The formula is Tn is equal to 8 a into r raised to the power n minus 1. Mind this, n minus 1 brackets, the whole n minus 1 term is in the form of a power, so a into r raised to the power n minus 1. Here Tn is equal to the nth term which you want to find out of the GP. The nth term of the GP, a is equal to the first term of the GP, n is equal to the number of terms in the GP, and r is equal to the common ratio. Now let us take an example. Find out the 7th term in the series 3, 6, 12, 24. What is the first thing that you need to do? You need to cross check whether this series is a GP or not. How do we do that? This is a GP since second term divided by first term, the latter term divided by the former term. 6 by 3 is equal to 2. 12 by 6 again is equal to 2. 24 by 12 again is equal to 2. The ratio is same throughout, which means this is indeed a GP. Now only you can apply the formula. So okay, let us start applying the formula. R here is 2 that we have found out. The first term a is equal to 3, and since we have to find out the 7th term, n will be equal to 7. So we have to basically calculate T7, the 7th term. How do we calculate it? The formula is T7 is equal to a into r raised to the power n minus 1. And now we'll be putting the formula, we'll be putting the values in the formula. So a is 3, n is equal to 7. So T7 is equal to now 3 into 2 raised to the power 7 minus 1 in brackets. So this is basically 3 into 2 raised to the power 6, and 2 raised to the power 6 is equal to 64. How? 2 into 2 into 2 into 2 into 2 into 2, 6 times it would be 64. That is why we have replaced 2 raised to the power 7 minus 1 by 64. 2 raised to the power 7 minus 1 is equal to 2 raised to the power 6 is equal to 64. So what is the third term now? 192. You can check this also. Can you cross check? Yes, you can. So you please do that. Now let us take one more example. Find out the 6th term in the series minus 5, minus 15, minus 45, minus 135. First thing that you do is ascertain whether it is a GP or not. This is a GP. Why? Since minus 15 divided by minus 5, latter term divided by former term is equal to 3. Likewise, third term divided by second term minus 45 divided by minus 15 again is equal to 3. Fourth term divided by third term minus 135 divided by minus 45 again is equal to 3. So basically this is a geometric progression, and now we can apply the formula that we have for the nth term of the geometric progression. Here r is equal to 3, that is now clear. Then a is equal to minus 5, you know that, the first term, and since we have to find out the 6th term, n will be equal to 6. We have to find out. Okay, there's probably a mistake here. T10, it should have been T6. Please do make this correction. T10 would mean the 10th term. However, we are trying to find the 6th term, so there's a mistake here. So what you do is, instead of T10, you need to note down T6, and T6 would be equal to a into r raised to the power n minus 1. A will be minus 5, r is equal to 3, and since we are trying to find out the 6th term, n is equal to 6, and the formula now basically is T6 is equal to a into r raised to the power n minus 1 is equal to minus 5 into 3 raised to the power 6 minus 1, or minus 5 into 3 raised to the power 5, 3 into 3 into 3, so on 5 times, it becomes 243. So the answer that we get is minus 1215, minus 1215. You can again check it out. Okay, so let us discuss one more example, slightly different one. Now here is a slightly different series. We need to again find out whether it is a geometric progression or not before trying to find out the sixth term of this series. So how do we do that? Again, we have to divide the latter term by the former term. So we are trying to do that. Second term divided by first term, 256 divided by 512, it is equal to 1 by 2. Likewise for third term divided by second term, 128 divided by 256, again 1 by 2. 64 divided by 128, again 1 by 2. So indeed this is a geometric progression and the value of r is 1 by 2, absolutely. Now the first term is a, 512. Since we have to find out the sixth term, n will be equal to 6. We have to calculate again. There's again this very mistake again here, so do excuse me for this. Do make this correction in your notebooks. This is not t10 that we are trying to find out. We have to, since we have to find out the sixth term, it should have been t6. So t6 should have been equal to a into r raised to the power n minus 1. A is equal to 512 into r is equal to 1 by 2 raised to the power 6 minus 1. Now basically it means what? 502 into 1 by 2 raised to the power 5. And what is the value of 1 by 2 raised to the power 5? We have already done this exercise in the class when we started off the semester. So you can do this. 1 by 2 raised to the power 5 will be equal to 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 5 times, and it would come out to be 1 by 32. That is what has been shown here. So that is why we get 512 into 1 by 32 and the answer is 16. So you can again cross check this, though it would not always be, again it would not always be possible for you to cross check it. Say if somebody is asking you to calculate the 25th term, you're not going to do a cross check, but here you can at least do a cross check. Now just as in AP, we can also find out the sum of first n terms of a GP. How do we do that? Let us discuss the formula. The formula is slightly different. The formula here is S is equal to A into, now please concentrate on the equation and don't get confused, because though it looks very much like the earlier formula that we had for calculating the nth term of the GP, but it is very different. Here A into, in brackets, r raised to the power n minus 1 divided by r minus 1. Is this okay? Bear in your mind that this is r raised to the power n minus 1. So here the power is n, while there when we were trying to calculate the nth term, the power was n minus 1. So you have to bear this difference in mind and don't get confused between the two formulas, right? So the sum is equal to a into r raised to power n minus 1 divided by r minus 1, but this formula is applicable only when r is greater than 1. If however r is smaller than 1, what you do, you don't have to do much. You only have to do what? Sum is equal to a into, now this time instead of r raised to the power n minus 1, it would be 1 minus r raised to the power n. Likewise in the denominator also, instead of r minus 1, it would be 1 minus r. So you just need to remember the first formula, and from that particular formula you can deduce the formula for r for the case when r is less than 1. So I'm repeating the formula for the second case. Sum is equal to a into brackets 1 minus r raised to the power n divided by 1 minus r, and this is the case when r is equal to, when r is less than 1. Here S, again sum of first n terms of the GP, n is equal to number of terms, a is equal to the first term of the GP, and naturally you know r is equal to the common ratio. So these are the two formula that you have to keep in your mind. The first thing that you will have to do is ascertain whether it is a GP or not. Second thing that you have to do is find out whether r is greater than 1. or r is less than 1. In the last example that we discussed, you would recall that r was less than 1, the value of r was equal to 1 by 2. You can go back and have a look at that portion of the video. The last example that we discussed, we found out that r is equal to 1 by 2, which means r is less than 1. So in that particular case, if we have to find out the sum of first n terms, we will be using the second formula. Is this fine? In the first two examples that we discussed, r was greater than 1. So in those two examples, if we have to calculate the sum of first n terms, we'll be using the first formula. Is this okay? But now, mm, there's a bad news for you. The bad news is you'll have to learn two more formulae. This, what we have discussed as of now, is the sum of first n terms of a GP. And basically this is sum of first n terms of a GP of a finite GP. Finite GP means you know as to what the last term is. The last term is not infinite. The last term is not infinite. You know what the last term is. But then there can be infinite GP. There can be a GP which extends up to infinity. The last term you cannot calculate because it is infinity. So in the case when you have an infinite GP, which means a GP in which the last term is infinity, or the series which extends up to infinity, in those cases you will have to use a slightly different formula. So let us understand what that particular formula is. If you have to find the sum of first n terms of an infinite GP, infinite in bold, so infinite GP, infinite means the GP extends till infinity, the last term is infinity. What you have to do, a very simple way of deducing the formula for an infinite GP is just remove the r raised to the power n minus 1 or 1 minus r raised to the power n, these two terms from the respective formula. So if you would recall, and if you can also have a look at the this very slide, the first formula for r greater than 1 was s is equal to a into r raised to the power n minus 1 divided by r minus 1. The first line here on this slide, and this is the formula when r is greater than 1. But this was the formula for a finite GP. But if the GP is infinite, what are you going to do? You only have to remove the r raised to the power n minus 1 portion. Again, if you're trying to find it out, if you're trying to find out the sum of first n terms of an infinite GP, in cases when r is less than 1, again what you have to do, you have to simply delete this particular term, 1 minus r raised to the power n, and based on this, if you do this, you will get this formula: s is equal to a divided by r minus 1 when r is greater than 1. I have simply done what? I have simply removed the r raised to the power n minus 1 from the original formula for finite series. So this is when the GP is infinite, it extends till infinity. And when r is greater than 1, when r is less than 1 and it is an infinite GP, it extends till infinity, the sum would be a divided by 1 minus r. Is this okay? Do you understand how to remember this formula? Yes. Now let us move ahead, do some questions so that we can have a better grasp of these concepts. So this is example number 1. Find out the sum of first 7 terms in the series. Now please understand, is this a finite series or a infinite series? Can you calculate the 7th term? Can you calculate the 7th term? Yes, you can. And that is why it is going to be a finite series. Can you calculate the 7th term? Yes, you can always calculate the 7th term. That is why it is a finite series. The 7th term is not infinity. Okay. So first thing that you have to ascertain is whether this is a GP. Yes, this is a GP. 6 by 3 is equal to 2, 12 by 6 is equal to 2, 24 by 12 again is equal to 2. So basically, yes, the ratio is same across. That is why it is a GP, and the common ratio is r is equal to 2, that we can see here in the second line. The first term is 3, and since we are going to find the sum of the first 7 terms, n again is equal to 7. R is greater than 1, that you can also see, and that is why the sum will be a into r raised to the power n minus 1 divided by r minus 1. Finite series, this is the case where we have got a finite series plus r is greater than 1. So this is the formula that we are going to use. You can go back to the earlier slide and cross check for yourself whether this is the formula that we have to use here. This is a finite series number 1 and r is greater than 1. This is the case, and that is why we are using this formula. Now let us put all the values here. A is equal to 3, r is equal to 2, and n is equal to 7, and what else is left? Nothing. So if you use this particular formula, you will get the answer like this: 3 into 2 raised to power 7 minus 1 divided by 2 minus 1. So 2 raised to power 7 is 2 into 2 into 2 into 2, 7 times 128, minus 1, 127, and denominator is 2 minus 1, 1. So 127 divided by 1 becomes 127, and that is why the calculation is like this: 3 into 127, and we are getting 381. You can cross check it for yourself. Keep doing these questions on your own in your notebook. Only listening to this video lecture is not going to help you out. Okay, so this is what you have to do. Again, I'm reiterating the same point. Please understand that there is a difference between this formula wherein we have to calculate the sum and the formula which is used to calculate the nth term. Here r raised to the power n, only n, there is the power is n only, r raised to the power n minus 1, wherein there the power was n minus 1. So there's a difference, and please ensure that you are really clear about this difference between the two formulae. Now let us take one more example. Before that, can you cross check it? You know that every second term is twice the first term, so every other term is just twice of the last term. So 3 into 2 is 6, 6 into 2 is 12, 12 into 2 is 24, 24 into 2 is got to be 48, 48 into 2 96, 96 into 2 192. I have added up all of them, 381. Yes, our answer was correct. Now let us move over to some more examples. Find out the sum of all the terms in the series. Now what do we mean by all the terms? If the series moves in this particular fashion, every other term is the double of the earlier term. 3 into 2 is 6, double of 6 12, double of 12 24. Where do you think this series will stop? What will be the last term? Don't you think if you keep doubling, every other term is the double of the last term, that the last, then if you keep on moving ahead, at one point of time you will be reaching the infinity? Basically what I'm trying to tell you is that this is an infinite series. All the terms in this series you have to find out. Find the sum of all the terms, and the last term has to be infinity. So that is why it's going to be an infinite series, and that is why the formula here would be slightly different. So first thing that you have to again cross check is whether this is a GP or not. So it is a GP. 6 by 3 is equal to 2, 12 by 6 is equal to 2, and 24 by 12 is equal to 2. So r is equal to 2, common ratio a is equal to 3, as n is equal to infinite. Why? Sum of infinite terms has to be found. So n is infinite, and that is why we are going to apply the formula which is for an infinite GP where r is greater than 1. Because r is greater than 1 here, r is equal to 2, so naturally you have to apply this particular formula. S is equal to, and the formula is S equal to A divided by r minus 1 when r is greater than 1 for an infinite series. We have discussed these formulae earlier. So this is what you will be doing here. You will be putting in the values and the answer will be 3. This is okay. Now let us try and find out the sum of the first 5 terms in this particular series: 4000, 2000, 1500. So what are we going to do first? First of all, we need to ascertain whether this is a GP or not. Yes, indeed it is a GP. Why? 2000 divided by 4000, 1 by 2. 1000 divided by 2000, 1 by 2. 500 divided by 1000, 1 by 2. So the common ratio, you can understand, it is equal to 1 by 2, and it is same throughout. So it is a GP. But here r is less than 1. 1 by 2 is less than 1. So here, and again this is an infinite series. A is equal to 4000, I'm sorry, it's not an infinite series because you have to find out the sum of the first five terms in the series. So we know the fifth term can be somewhere around 250. So it's not an infinite series. So here we'll be applying the formula for an infinite geometric progression wherein r is less than 1, and the formula is this. We'll be putting in the values. Keep doing these things on your notebook as well. In fact, you solve the question on your notebook and cross check the answer uh, with the answer that is being given to you in the video lecture. Okay, so now once we do this, I think you'll get this answer 7750. One particular point where you might find the calculation a little difficult is when you have to calculate. Have a look at the second line, 4000 into 1 minus 1 by 2 raised to the power 5, right? Because you have to calculate the fifth term. So 1 minus 1 by 2 raised to the power 5. Now what is the value of 1 by 2 raised to the power 5? 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 is equal to 1 by 32. Okay, so after that you can do all the calculations, and in denominator we have 1 minus 1 by 2, same second line, 1 minus 1 by 2. So 1 minus 1 by 2 becomes 1 by 2, and what I've done is I have, since 1 minus, in the third line you have a look at the third line, 4000 into 1 minus 1 by 32 divided by 1 by 2. So what I've done in the next line, just like we had discussed in the class, what I've done is 1 by 2 I have converted into its reciprocal and I've multiplied it. You would remember that this can be done for division operations. We can do it this way: the denominator can be multiplied after it has been converted into its reciprocal. So that is what I've done here. I have actually not divided by 1 by 2. I have found out the reciprocal. The reciprocal would be 2 by 1 is equal to 2, and I've multiplied the numerator by 2, and this is the answer that we'll get. We can cross check it. You can understand that if the series progresses in this manner, the fifth term would be, every other term is half of the earlier term. So 4000 becomes half 2000, 2000 becomes 1000, 1000 becomes 500, so 500 got to become 250. So we can do a cross check. So we are cross checking 4000, 2000, 1000, 500, 250. We are adding them all up and we get 7750, which means our answer was correct. Okay, let us do one more question. Now here, find out the sum of all the terms. All the terms means you have to keep on moving. All the terms, all the possible terms, you have to keep on moving, which means basically it is an infinite series. So whenever you come across this particular term, whenever you come across the word all, you should understand that basically the series is an infinite series. So find out the sum of all the terms in the series. Again, you will understand that this is a GP. Here a is equal to 4000. The common ratio is equal to 1 by 2, 2000 divided by 4000, 1000 divided by 2000, 500 divided by 1000. The common ratio is equal to 2. As you know that since we have to find out the sum of all the terms and will be infinite, and that is why we have to use the formula which is for the infinite GP series wherein r is less than 1, and this is the formula that we have. And you can calculate now the sum. You will put in the values and again you will do the calculation. You please keep doing these calculations on your notebook. The answer will be 8000. Okay, so these are the various problems. I think we have discussed problems of each type, and now there are some questions for you to do your self-assessment whether you have understood the topic or not. You might find two or three of these questions a little difficult to attempt, and that is why I shall also be giving you some hints. So please attempt these questions uh, at your home, and please ensure that you are thoroughly prepared with geometric progression. Thank you very much.